All right, so in this last video, we defined the inverse of the sine function. We're going to now talk about the inverse of the cosine function. And we're going to define that inverse to be called the arc cosine. All right, and so a quick recap of what we did last time. So we had this thing we called the sine function. It's not a one-to-one function. So to define the inverse, I had to look at a restriction of the domain where I only looked at the values of theta between minus pi over 2 and pi over 2. And essentially what that does is we just ignored everything outside that domain. And now we can deal with this. In this particular function, if we do that, I would think about this in terms of the unit circle. This is angles of theta from minus pi over 2 to pi over 2. So it gave me points on the circle in either the fourth or first quadrant. So I'm basically working with these points depending on which angle that I use on there. Now, if we think about the cosine, cosine has exactly the same problem. It's not a one-to-one function. So we're going to have to restrict the domain. And just like before, we have to agree in advance on what that domain is going to be. Because everybody's going to have a calculator. And we all have to decide how to interpret what those numbers mean when we get them out of the calculator. Okay, so again, I could pick a lot of things. I could go from here to here, or here to here. What we do is we decide to go from 0 to pi is the choice that we make. And again, it's somewhat arbitrary. I could go from minus pi to 0, but this is just what we use, right? So we're going to use this for our domain, and it's going to include 0 and pi, and it's going to give us values for y from minus 1 to 1. Okay, so if we do this then, our values of theta are between 0 and pi, and let's see, in terms of which quadrant that means, so let's do this. So this is our function now that we're dealing with cosine. I'll be careful here. So this is the x value, theta value. Okay. If I look at angles from 0 to pi, those angles are going to take us in the first and second quadrant. So if I let that angle go from 0, right, so that I end up with a point here and march around to there. Right, so these angles of theta are going to sweep out in the unit circle everything in the first and second quadrant. Okay, so what this means then is that as long as theta is between 0 and 2 pi, and I tell you that x equals cosine of theta, I can take the inverse cosine of both sides, and as long as that value of theta is in between there, I'm going to get the theta. So the arc cosine, of x is going to give me theta. All right. So let's just do an example. So let's see. So I want an angle that's in the third quadrant. Be between 0 and 2 pi. I want the cosine of that angle to be negative 0.3. Okay, so I want to figure out what that angle is, and I want to use my calculator to do it. It's going to be the third quadrant, so angles from 0 to pi aren't going to be able to find this angle. So let's redo this. So what's the idea? So it's negative 0.3, so it's somewhere up here. So let's call that angle psi. If I use the arc cosine, it's going to give me that angle, but it's going to be in the third quadrant. So I need to look at all the angles whose x value is minus 0.3. So I'm looking for this angle right there. Okay? So we need to go from there to there. Okay? Now, let me see. So notice the reference angle associated with theta here, called alpha, is there. And it's going to be the same reference angle as that. So that means this angle right here is going to be minus psi. Okay? But I want the angle, this is a bit of a mess, let me get rid of some of this. I want the angle from 0 to 2 pi, so it can't be minus psi. I want this angle right there that goes from here all the way around. And the thing to notice is that if I take theta plus psi, I'm going to get 2 pi. All right? So theta then is going to be 2 pi minus psi. And psi is going to be the angle that I get from the arc cosine here. So let's see. So this is going to be theta equals 2 pi minus, so looking at this, if I take the arc cosine of both sides, I'm not going to get theta. Instead, I'm going to get this angle over here rather than this angle that goes all the way around. So this is going to be the arc cosine of minus 0.3. I can plug that into my calculator, and I get about 4.41 radians. Okay? So that's kind of complicated, and you need to stop and think about that. But it's a little bit weird. What the heck is going on here? It is that if I want to take the cosine of the arc cosine, the question is this thing x? Okay, well, let's see. This is going to give me an angle. The arc cosine gives me an angle, okay? So if I take the cosine of that angle, I know that its cosine is x. So, yes, that's going to work. There's no problem with that, okay? Let's turn this around, though. What happens if I take the arc cosine of the cosine? Now, by definition, if x is between 0 and pi, everything is fine, okay? Right, so if x is between 0 and pi, there's no problem there. By definition, it's going to work, okay? And the thing is, the arc cosine itself is restricted to working with angles between 0 and pi. Okay? So if x equals 7 pi over 4, for example, what angle is that? So that's going to be pi over 4 less than a full circle. So, oops, I'm calling it x, sorry. Okay, so x is that thing right there. The cosine of 7 pi over 4 is going to be square root of 2 over 2. Okay. But now if I take the arc cosine of this, that's going to be the arc cosine of square root of 2 over 2, we've defined this function to only work in net in terms of its range. So if I go back to here, I'm only working with angles that are going to give me this part of the unit circle. And the only one that's going to give me that is going to be that angle right there, which is pi over 4. So the angle whose cosine is square root of 2 over 2 between 0 and pi is going to be pi over 4. And so notice the cosine of the cosine of this angle is not the same thing. Okay? So this restriction is very important in terms of how do we define this inverse function.